Okay, this is a really interesting problem. This doesn't require at least anything of linear algebra. Okay, I love this problem absolutely. So this type of questions, actually, remember this type of questions came in ISI. Okay, when I was in second sem. So it was an open notes examination, and there you need not any mark up any formula. Okay, just enjoy the problems. And I love one of them problems was this. Let's do this problem. Okay, it's a square matrix and it's integer entries. And that is, let's say an example, A, B, C, D. They're all integer entries. Its determinant is plus minus 1. So it's asking that A, x is equal to 0 has has a integer solution or not. These two are integer coordinates. X belongs to z to the power n or not. Let's say like integer coordinates or not. That's the question. That's the question, guys. Okay. So let's when you're trying to do this problem, guys, let's say what would have happened if x and y are not. See, if x was not required to be an integer, does it have an integer solution? Does it have a unique solution, guys? Okay, sure, Pratik. So what do you think? Yeah. So Tishika, Bhushan, Sneha, Hasuda, Sriteja, Nisha, Shoikot. What do you think that suppose x was not required to be an integer solution, then does there exist a solution? Unique solution? What do you think? And all the YouTube people over here. Suppose x was not required to be the integer coordinates, okay? The question is now mine that will it be an unique solution? Does there exist a solution? What do you think? Sneha, Vasudha, what do you think? Nisha? You think yes. Why do you think? Like, what is the reason? All the YouTubers, YouTube people over here. Exactly. A is full clear lang. Lovely. A is invertible, right? A ka determinant is non-zero. A ka determinant is non-zero. Therefore, inverse exists, right? You can clearly understand that A ka determinant is non-zero and inverse exists. So, if x was not a given condition that x has to be an integer, you take x to be A inverse of z, A inverse of y, right? And if there exists a solution, so you have to understand this. If there is a solution, it has to be only A inverse of y. Try to understand this, that if there exists a solution, since it's invertible, A inverse exists, the only solution is A inverse of y, right? So what does the question reduce down to? The question reduces down to the fact that whether A inverse y is an integer, the coordinates are integer or not, right? That's the question reduced down to. So the only solution that can exist is A inverse of y. So the question therefore boils down to ask that whether A inverse or y has an integer coordinates, if A and y has integer coordinates or not. That's the only question it reduces down to, right? That's the only question that we are going to focus on now. So therefore, let's focus on this problem now, a subpart that is A inverse y integer? Is A inverse y, does A inverse y contain integer coordinates, integer entries or not? We know that A contains integer entries. We know that. Now we want to know that whether A inverse contains integer entries or not. I'm really sorry for my bad handwriting, okay? Please forgive me, but I will try my best. Okay, so the question therefore boils down that if given A has integer entries, whether A inverse of integer entries or not. Now, a small hint for you for next 1-2 minutes is that, can you use the condition now that the determinant is plus minus 1? can you now infer about the entries of A inverse? Do you remember how the A inverse is created? Do you remember the algorithm of how A inverse is created? Can someone tell me how A inverse is created? What is the algorithm of A inverse? How is the inverse matrix is found out? Can someone tell me? Yeah, perfect. No, Pratik, one thing is sorry, Satej, one thing is that yeah, the inverse is unique. Okay, and since it's invertible, it has only left inverse is equal to right inverse. You can prove that. Okay, that's not a that's not a problem, Satej. The problem is that uh, whether A inverse Y is integer or not, because now we can. There's only one possible. Okay, yes, exactly, perfect. Swandan and Pratik, that A like the in A inverse the entries are what? Adjoint of A at that point, adjoint of A by determinant of A. And determinant of A is plus minus of 1. So what we get now? Determinant of A is plus minus 1. So therefore it boils down whether adjoint of A is does contain integer coordinates or not. So we know that A inverse is equal to adjoint of A by determinant of A. That's how we form. Now therefore it's equal, therefore it's plus minus adjoint of A. So therefore it boils down that therefore I ask the question that whether adjoint of A contain integer entries or not. That's the first question now. So can you guys tell me what is the definition of adjoint of A? Tishika, Sriteja, Vasudha, Bhushan, Sneha, Nisha. What is the adjoint of A?
Transpose of cofactors.
Exactly, cofactors. How do you find out adjoint of A? Suppose A is here. So how do you find out the adjoint of A? This is the algorithm. You for the ijth entry, what you do, you delete this two columns and rows, and whatever matrix is left, you take the determinant of it, depending upon the like minus 1 whole to the power position I plus j, I guess. The ijth entry of this is actually like deleting this two this rows and column, whatever the matrix is left, which is the determinant, and A contain all the integer metrics. Therefore, each of adjoint of A ka ijth entry is integer. Why? Because A ka like determinant of a matrix with integer entries are integer, is an integer. Right, guys? All of you understood this? Any doubts? Determinant of an integer matrix with an integer entries is an integer, right? So therefore, what we have got over here, we have got therefore the adjoint is an integer, and therefore the A inverse must be an integer. It's a beautiful problem. A inverse must have integer coordinates. Must have integer entries. And therefore, A inverse of y is also integer entries, must be all integer entries. Integer entry. And therefore, it's true actually. Yeah, so okay, so that's a very good question about asking that how that person should write that adjoint of integer is adjoint is integer. That's why exactly. So you write this that adjoint of A ka ijth entry is what? Is actually determinant of a matrix with integer entries. Since A has integer entries. Maybe you can draw a picture like this. They will understand. I mean, surely if you draw this picture, they will understand. This is a way to write. Okay, thanks for asking this question. Yeah, sure. At least they expect this kind of mathematical maturity from you, Pratik. Okay, that they expect it from you.